Hi, welcome to episode 57 of the ChessTDD series. What I'm starting off with here, real quick, before I get to explanatory announcements, is I got a comment on some vehicle or another, maybe Google Plus. Someone pointed out that I had made changes to the test code without remembering to change the corresponding names. So I went in and checked it out, and sure enough, this was a comment on maybe 6 episodes ago, and still hadn't fixed it. So what I went and did here is kind of go through these test methods one by one to see where all I had forgotten to flop the name. I guess this had been after I had had struggles with transposing the coordinates, and that was causing test problems. So got them untransposed, but never updated the test name. So that's what I'm doing here. Now, explanation-wise, once again, it has been a while between episodes. I'm looking to do something about that. I am now spending the winter somewhere warm, and I'm kind of like holed up away from where I can really have any meetings. So I'm hoping to make a lot of progress, not just this, but on my book, which you can check out on LeanPub if you have not yet heard of it or seen it. Anyway, I'm hoping to do a lot of content generation over the course of the winter because I am sort of displaced from my normal life and holed up hibernating. Well, no, not hibernating. It's nice here. But anyway, you get the idea. So, the other thing to explain is that somewhere around the 18-minute mark, it was particularly windy last night when I was doing the codecast, and we lost power for a few minutes. That had the effect of when that happened, I thought, oh man, I've lost the code cast. So I'll just like undo the, commits and start all over. And that's a little hokey because it's a second trial run, but I didn't know what else to do. Well, Camtasia, much credit to Camtasia, actually saved the code cast. I was able to recover it. But the Visual Studio source file, the C# file, somehow got borked in there, and it was just filled with nulls or something crazy. I couldn't open it in Visual Studio, so I actually had to revert it and then take a couple of stills and kind of recode by hand everything I'd done. So it is possible that you will see source code that maybe there's like a word misspelled, or I don't know. There could be a spacing or some relatively cosmetic difference between what you see in the first part of this clip, I guess up until like the 18-minute mark or so, and what the source code winds up looking like. So I'm not trying to pull a fast one. Don't think that all along I've been, I don't know what, but if you see that discrepancy, that's what caused it. Okay, so back to the moment here. As I said, it had been a while, so I was kind of trying to remember what all happened and what all I had been working on and what the production code was doing exactly. Now, I think the production code here is pretty readable, but I kind of like to just sort of confirm if I've been away for a while. Instead of taking the production code's word for it, so to speak, I like to kind of almost black box style write a test or two that should be true anyway, and just kind of confirm or deny, I guess, my understanding of what's going on. So as long as you're writing tests that have some kind of value, there's no harm in that. I mean, if these are tests that I want to write, so this wouldn't necessarily be strictly test-driven development, but these are good unit tests to have anyway. Like, this is true, that we should, in terms of threats, return true for a square that's kitty corner to the king. So diagonally away from the king, that should be a threat. So if this test doesn't pass, then I know what I have to do next. But if it does, then, well, that's okay. I mean, this is a test that needs to pass. So that's why I do that particular practice. So then this test went green, and looking at the code, that wasn't unexpected because the thrust of that code is to figure out where a piece, what moves are available to the piece, and then to say, well, if a piece can move there, that square is threatened. So it wasn't a surprise to me to see that test pass. But I kind of wanted to, run the experiment instead of, and I encourage you to do this in general, instead of kind of squinting at source code and trying to imagine all the different possible scenarios of what it might do, Just write tests to confirm it. It's a great way to experiment, especially if you've got something like ncrunch going here with the continuous feedback loop. There's no faster feedback than writing tests to see what the code is going to do. If you are used to like running code in production for a specific scenario, or I'm sorry, not production, but running the code, running the application to see what it would do, that's a long feedback loop. Even, executing all of the unit tests is kind of a long feedback loop. This is a really short feedback loop, so it is great for experimenting with the code. And I wholeheartedly recommend it. In fact, I wholeheartedly recommend getting a tool, whether it's ncrunch. I mean, ncrunch is a tool I definitely recommend, but anything to get that feedback loop tight, that is absolutely critical. So kind of back to the task at hand here, I'm just writing tests, and I wanted to confirm that basically, so up till now I've been using king and rook, and basically king and rook, those two pieces, anywhere they can move, they can attack. By writing the king, I was sort of advancing my cause by confirming non-adjacent attacks. By using the... Oh, I see. I'm debugging there. I thought, as I was narrating, I thought Camtasia was frozen. And by using the pawn, I can see, well, this is a situation where there's a piece that can move somewhere, but they can't attack with that move. So that's new to what we're doing. And I was expecting this test to be to fail, because it shouldn't, I haven't implemented that yet. All I've done so far is to say anywhere a piece can move is a threat. And then I wanted to say, well, except for a pawn, if I move a pawn up one, that shouldn't be a threat. And when I ran that test, since I hadn't implemented, I was expecting it to fail. It passed. Now, I do a good bit of stepping through this code, and what I failed to consider, and I think this calls out pretty well that I am not done when it comes to reasoning about first and second player. What happened is I didn't notice that that I was actually putting black pieces on the white side of the board, because all I had been caring about up until that point is creating a piece of the opposite color from the one that I was eventually going to check. So whether it was black or white, it didn't matter. So I passed in false when creating the piece, which creates a black piece because it is first player. And then when evaluating whether the piece was threatened or not, I was passing true. So it's a white piece. Now, what's going on here is that the pawn movement is unidirectional. So, oops, of course, this is returning false, because if I put a black pawn on 1-2, that pawn can only move to 1-1. It can't move to 1-3. So I was passing for a spurious reason. It's passing because it's a poorly written test, or it's not testing what I want it to be testing. So what I did, just to confirm my understanding here and to get to red, a properly failing test that I was looking for, is I inverted these Boolean values. Now, the reason I had kind of alluded to this not being ideal is I am using a Boolean here in a slightly awkward way. I'm using it as data, and what that results in is me passing Booleans into a method, which is often... which is a smell, because usually you're doing that as some kind of like state flag switch. Like you pass a Boolean into a method, and then in there that method's like, well, if, I've been passed this particular value of the Boolean, if I've been passed true, then I'm going to do this one thing, otherwise do this other thing. That's not what I'm doing here. I'm using a Boolean as data, but this is a case where this is not a particularly elegant solution, because you don't think of the two sides of the board. You don't think of the black and white players as true and false. You think of them as black and white. And this is a good example of where using a primitive type that way is fomenting misunderstanding. I have a problem here. I have an improperly passing test, specifically because I'm passing around Booleans instead of something, if this said new king white and new pawn black to 1-2, it would have been a lot more obvious to me what the problem was. But now that that's sorted out, what I'm going to do is... Wait a minute. I wonder if I talked over them. So at first I... there we go, yeah. At first I only changed the 1 around because I wanted to get to properly failing, and then I wanted to get to passing before I started refactoring. And then as I was doing that, I thought this is pretty suboptimal that that I had this boilerplate where when I wanted to switch the color scheme, I suddenly had to, change every test method. So I put a card in there to say, like, I'm going to pull something out where I abstract all this stuff, and then, oh, I see. I did the refactoring when it was green and then moved on. Okay. Sorry about that. But nevertheless, the lesson remains. Number 1, if you're going to do refactoring, make sure you're green when you do it. And, I forget what the other lesson was. Oh, well. So now, how to go about making this true. I remembered that at some point there was some method, and I think it's on piece, that in essence says it differentiates between... there are all the possible moves you can make, and then there's attacking and non-attacking moves, I called them. So what I wanted to start doing is tapping in here to disqualify in this particular method on the basis of whether something is an attacking move or not. So when we're looking at threats, I don't want all the moves that a piece is allowed to make. I want all the threatening moves that a piece is allowed to make. And I see that this is capture allowed. Basically, the default in is capture allowed for piece, unless we override it in something like pawn or king or whatever, is capture allowed will be a function of just returning true. So for pieces like rooks and bishops, queen, if those pieces are allowed to move somewhere, they're allowed to capture there. When it comes to the pawn, not so much. So that's been a good scheme up to this point. But I started to think of, is returning true from that method really the best thing to do? So the first thing I want to do is get this method to passing. And my hypothesis is that if we update this lambda expression within the any to say, not only do we need a square that matches where the victim is, but for this piece, capture has to be allowed there. This is perfectly reasonable. I mean, I'm pretty sure this actually made the test pass, but I was kind of already thinking ahead at this point to what I might want to do. Now, an important lesson here is if you get yourself in that mindset, don't let planning ahead stop you from doing the simplest thing that you can get to work. It's okay to plan ahead. It's okay to know what you want to do later, but don't let that stop you and just kind of short circuit the whole thing. Get to green as quickly as you can. So getting that to green is a good step. Now the pawn case is passing and working. So at first I thought maybe I can extract that and see what it'll look like. And I did it, and then that was hideous. And it wouldn't really have helped my cause here anyway. So I think the next thing I'm going to do is like, well, what if I just move that piece clause out? And so I'm going to say like, well, okay, the piece isn't null. And then will this work if I just say is capture allowed and nothing more? And the answer is no, it's not going to, because it's returning true for everything. So when I scroll up and I look, hey, it's good that I've got this this test involving the rook here, because what's happening is even though the rook isn't allowed to move there, that rook's overload, the rook's non-overload of that method means that it's the piece is capture allowed method, which is just return true. So if you pass is capture allowed to absolutely any square on the board for rook, it will return true. And so at this point I thought, well, that's not an ideal implementation in the first place, because even though the rook can't move there, I shouldn't be relying on that. Like, is capture allowed is a public method, or it's an accessible method. I forget what the actual visibility is, but it shouldn't rely on another method having been called and preempting bad implementation. So I should get here, and the default should really be not return true for any imaginable destination, but rather return basically the set of moves that this piece has. That should be the default. And I should probably have gone in and done that for his non-capture allowed, but it wasn't in my path. I wasn't really thinking about it. What I was trying to do is get this refactoring that I have in flight to work. And my hypothesis is that if I do this here, then I don't even need to worry about when it comes to threat. It actually makes sense that I wouldn't worry about anything but whether capture is allowed. Like I don't care where the threatening pieces can move in general. That doesn't matter. All that matters is what they can capture. And sure enough, there everything goes green. So now I can get rid of this more complex lambda expression. And this is a simpler piece of code here, which is nice. Does a square attack? Well, see if there's a piece on that square, and if there is, can the piece attack the victim square in question? And then I also remembered to remove that line of code I had in there for when I was debugging. Now I have another, this is the point at which I made an abortive attempt to refactor. What I wanted to do is have a method that sets up a white piece. You just pass in a couple of coordinates, and it'll add a white piece there to the board. And then you pass in, or then I was going to do a refactoring for the next one about is threatened, where you just, call this private method with another couple of coordinates, and that's it. The trouble was that I kind of hit as soon as I started writing this method, and maybe you noticed it, is that I have to specify the piece, and then the piece is immutable in terms of you can't create a piece and then change its color. And so I said, oh, well, I can't pass in a piece because then I'm not solving my problem. I've still got that true that's coming into every method. And I kind of kept going because I wasn't sure if the piece was mutable or not. So I thought, oh, well, let me try to set that to true here, but that doesn't work. It's immutable. And at this point, I backed out the effort. It was getting late in the episode. I still think this is something worth doing, and maybe I could. I thought of poking around in that ASCII board builder thing to see if could I just pass a letter for the piece type or something? I don't know, but it struck me that, well, maybe this isn't actually worth doing. It's not the most onerous piece of setup in the world, and I might have a scenario where I didn't actually want every piece set up on the board to be a white piece. Now that I'm thinking about it after the fact, the other thing I could have done is just added these pieces to the board in the setup, and then just known that the setup for this class was, some collection of white and black pieces or something. So I archived this card and said, not going to worry about that now. What I wanted to make sure I got in here was one more situation with testing where, let's see. If you look at right now, the is threatened method, what you'll notice is that Boolean parameter that's getting passed in is unused. So the main deficiency remaining in this method is I'm not taking into account color. So what I want to say is that if I've got a rook in its starting square, so I've got this white rook in 1-1, I want to, what I'm reasoning about here is threatened, depends on the type of piece. So is the square, let's see, what am I doing? Oh, this is, my apologies. I think this is where this is right around where the power outage happened. Anyway, let's see. Oh, that must have been it. Okay, so if I have a rook that I've stuck on 1-2, it should threaten 1/1 if we're talking for a white rook. If we're talking about a black piece, it should threaten 1/1. If we're talking about a white piece, so in both of these trues correspond to a white piece, this should not be a threat. And that's failing because I'm not looking at that. I'm just looking at, can the piece go there? But what I have to be looking at is whether the player and attacker have matching colors. Or I'm sorry, whether the attacker and victim have matching colors. Because if they do, then it's not a threat. But if they don't, then it's a threat. So I think the simplest thing I can do here is pass this Boolean on down into the does square attack method, and then add something in here that the piece's color is not equal to the threatened or the prospectively threatened square's color. So I passed that in, and now all of my tests are passing. So I am happy with that. And right around the 20-minute mark, I think I started to, do I write acceptance tests? What do I do? I kind of waffled for a minute. And what I wound up doing was just pulling this this test into production, because I tentatively think that this is done. It could probably use some acceptance tests and maybe some more careful thinking, and maybe I'll throw a few more unit tests at it. But I feel like when reasoning about it, I don't think there's anything more to do. So I'd say I'm done with 70% confidence. And when I'm done with 70% confidence, what I like to do is write more tests to, bolster my confidence. That's where I start to do some, I guess, exploratory testing. Like, what if I set up this crazy scenario with these pieces, off the top? Maybe I have a piece, and then, it's a rook, and I put a friendly piece in between it and make sure that it can't threaten some piece beyond the friendly piece or something. Need to flesh out situations like that. But I am moving it out of its incubator here and into the production code. Then I confused myself with namespace collisions, but sooner or later I got that straightened out. And once I got that straightened out, I gave the folder a bad name, which caused the collision. So once I did that, life looked good. Now everything's building. I think I ran a quick build to confirm. And then I went about committing this. And I did a little bit of housekeeping in Trello. This implement the concept of check, I think, is a little too big. So I actually created a checklist in here. None of this is an exact science. It's how I kind of keep myself productive. Implement. There we go. Implement the threat concept, which I've done. So I wanted to mark some progress here, but then I want to say integrating the threat concept back into the broader scheme here. Right now, this just exists in a vacuum, but it matters because of castling, actually, is where I'm going to implement that first. Probably also going to matter for king movement later, and that's something we'll have to do. But for now, I'm going to commit episode 57 and call it an episode. And as always, thank you for watching, and I will see you next time.